Okay, so the menstrual cycle is made up of two parts. You have what happens in the ovary, which we call the ovarian cycle, and we have what happens in the uterus, which is called the uterine cycle. I'm going to do the ovarian cycle first because we need to understand where the hormones are coming from, which then affects what happens in the uterus. If you have struggled with understanding the Graafian follicle rupturing to produce the mature ovum, that's what ovulation is, and then that becomes the corpus luteum, I would suggest you go over that first before moving on to the ovarian cycle because it is quite challenging. So we have two groups of hormones in this first part. We have what we call your gonadotropic hormones, which are hormones that act on the gonads. Now, gonads is the term for the sex organs, such as the ovaries in women and the testes in men. And these come from the pituitary gland or the hypophysis or hypophysis. Then you have your ovarian hormones, which are produced by the ovary or by follicles in the ovary. We're first going to look at your pituitary hormones. I just call them pituitary hormones, but I'm explaining gonadotropic for the purpose of this diagram. So we have two pituitary hormones, meaning they travel in the blood to the ovaries to act on the ovaries. The first one, this blue line, is FSH, otherwise known as follicle stimulating hormone. The nice thing is the name tells you exactly what it does. It stimulates the development of a follicle to eventually form a follicle containing a mature ovum. So that's pretty much this first part of the picture here. So the follicle develops into a mature Graafian follicle containing a mature ovum under the influence of FSH. That's exactly what FSH does. So FSH is high in the beginning because it's doing its job. It's stimulating the development of the follicle. Once you end up with a mature Graafian follicle, FSH can drop a little bit because it's at its maturest or most mature. And you will see a little spike in FSH when ovulation occurs because that helps to just make sure it's got the final amount of maturation that needs to be done. The other hormone is LH, otherwise known as luteinizing hormone. Now, luteinizing hormone actually has quite a lot of functions. The first thing that it does is it causes ovulation. So what I always look for is the hormone that is highest before ovulation takes place. And you can see that luteinizing hormone is doing nothing for the first 13 days. Come day 14, luteinizing hormone peaks like crazy. Because it's very important for you to note that this in the middle here is day 14. Ovulation always takes place on day 14. So luteinizing hormone peaks just before ovulation takes place. It causes the Graafian follicle to burst. The second thing it does, it's also kind of in the name, luteinizing hormone. It causes this ruptured Graafian follicle to convert into the corpus luteum. So the corpus luteum, luteinizing hormone, it's kind of in the name. And the last thing that it does is it inhibits the secretion of FSH. So FSH secretion must remain low after day 14 because if this egg or ovum is going to be fertilized, you don't want FSH being high to cause all of this to happen again to produce another ovum 14 days later, and now you're going to have a few fertilized babies in your uterus. So if fertilization takes place, this process of ovulation must not happen. You can't have different babies of different ages in your uterus. That's just weird. So luteinizing hormones, 3 functions. You must know them. I'm going to put it here. So luteinizing hormone causes ovulation and converts the ruptured Graafian follicle into the corpus luteum. It also inhibits the secretion of FSH. Now, what we can ask you here is we can say, did fertilization of this ovum take place? And what you always want to look for is the corpus luteum getting smaller. Because if fertilization takes place, that corpus luteum will stay nice and large because it secretes this hormone here, progesterone. So let's go look at the ovarian hormone levels. Remember, they're secreted by follicles in the ovaries. The estrogen is secreted by the Graafian follicle. We did that when we did oogenesis. So you can see that as this follicle matures, the estrogen secretion increases until this Graafian follicle would be at its most mature, which would mean that the estrogen levels would be at its highest because that Graafian follicle would be secreting a lot of estrogen. Progesterone secretion, the way I tell the difference between these two graphs if we didn't give you the labels, is the one that only gets high after day 14. Because day 14, remember, is ovulation. And then that Graafian follicle that's been ruptured is converted into the corpus luteum, which secretes progesterone. So progesterone secretion can only increase when the corpus luteum is present. So we've now moved on to the uterine cycle. But you'll see the way I've broken up this graph is I've cut off the irrelevant information. So now what happens with the pituitary hormones is not relevant because we've already looked at how FSH stimulates the follicle to develop, and then luteinizing hormone causes ovulation, converts this ruptured Graafian follicle into the corpus luteum, and then inhibits the secretion of FSH. So now we're only dealing with our two ovarian hormones, estrogen and progesterone, which are secreted by the follicles in the ovary. Estrogen secreted by the Graafian follicle and progesterone secreted by the corpus luteum. Okay, so let's look at the first 7 days of your uterine cycle. Your first 7 days shows you that the thickness of the endometrium is decreasing. So this is like a graph being like that's the thickest it gets and there's the thinnest it gets. So you can see here that the lining is being shed. This is as a result of last month's ovum not being fertilized. So if you ever asked, did fertilization take place in this cycle, you can't say no because menstruation took place. This egg has not even been produced when this menstruation is taking place. So this shedding of the uterus or of the uterine wall, the endometrium, takes about 7 days. So it's normally from 0 to 7 days. Then what you can see here is the membrane, the endometrium, gets thicker and more vascular, which means more blood supply, and more glandular, which means it has more glands in it. So these are all glands, these purple things, and that's blood. So the reason that this is increasing in thickness can only have to do with estrogen. You can see that estrogen starts to increase, and a day or two later, the endometrium starts to get thicker as estrogen secretion increases. So that's not at its maximum yet at day 14. Remember, very importantly, ovulation takes place on day 14. So that's when that egg cell is released. And pretty much the estrogen has been creating a lovely environment inside that uterus, make it nice and thick for the egg cell, if it were to be fertilized, to be implanted. So what the estrogen does is it prepares the uterus for implantation by making it thicker, more vascular, and more glandular. So it does those three things because remember, we're dealing here with implantation, which is a fertilized egg cell. It won't just be an egg cell. Implantation can only happen if the egg is fertilized or if it's an embryo. The next hormone that comes in, remember, is progesterone, which is produced by the corpus luteum, which resulted from the ruptured Graafian follicle. So progesterone secretion increases. Now progesterone's job, the way I remember shorthand, is it maintains pregnancy. But that's not a good enough answer if we ever ask you for the function of progesterone, because how does it maintain pregnancy? So if we look at this uterine wall, what you can see is actually when progesterone secretion increases, it becomes even thicker and more vascular, so more blood supply, and more glandular, so more glands. So it maintains pregnancy by making the endometrium thicker, more vascular, more glandular. So if that embryo were to be fertilized, then it could be implanted nicely into the uterine wall. So the embryo will remain attached. It can't attach to a lining that is too thin or a lining that is being shed. So in this question, has fertilization taken place in this cycle? So you have this ovum that has been released. in those 14 days, reminder that ovum is actually only liable or able to be fertilized. It lives for only 1 day. So you've got a very narrow window. But was that ovum fertilized? I can't say no it was, or no it wasn't because menstruation took place. No, that was for last month's ovum. I can't say yes it was because the lining hasn't shed. That menses or menstruation period only starts the next day, which you can't see. So what you're looking for is the degeneration of the corpus luteum. So you would say, no, fertilization has not taken place because you can see the corpus luteum degenerates. Or the other thing you can say is, no, fertilization did not take place because progesterone secretion decreases. If fertilization took place, progesterone secretion would remain high because it maintains pregnancy. You may need to watch this video a few times. It is a lot of information, but when we do past questions, you'll see the way we ask this graph. But you must understand the hormone levels. So we've got the 4 hormones. You must understand what happens in the ovary and in the uterus, and understand, has fertilization taken place? Did it take place last cycle? No, because menstruation is taking place. And then lots of new words here. You have menstruation, ovulation, implantation. So those are 3 new words that sound similar, but you cannot get them confused.